So let us continue with linear regression. We have seen that there is a model like this, and this is the way we calculate the error. Now, why this error is arising? If your data is something like this, the ideal model should be this way, which is y is equal to x. However, if the if the model is not correctly learned and it is y is equal to 2x, then you will get an error. Let us see what happens if we have x, if we have y, and we have y dash. So we have 10 10 20 20 and 30 30, but the prediction is 10 is y is equal to 2x, so it is 20 40 and 60. In that case, there is the large error because there is a difference between the actual and the predicted. This is actual and this is predicted. There is a difference here because the model is wrong. When I say model is wrong, the W and the C, W is the weight or slope and C is the intercept or also called as bias. This intercept and weight are wrong. It should be, weight should be 1. In this case, model is giving weight of 2. So we use a technique called as gradient descent, and with the help of this technique we reduce the error by updating the value of W and C. So to simplify the process, I am taking a very hypothetical example. Let the W be initially as 0 and C be initialized as 0. The model is Wx plus C. The data is like this: 10 20 30 and 10 20 and 30. When I give W as 0 and C as 0, so this is my step 1. So my model becomes y is equal to 0. In this case, so model will be the prediction. So we have got y is equal to 0. Here we have got y is equal to 0. That means, what is the model predicting? Model is predicting everything as 0, which means there is a huge error. So in the next iteration, what gradient descent does is it updates the weight. So we have W new is equal to W old minus some, so there is a step size and some, let us we call it derivative. So we will not go into the details. So what it does is, the W old was 0 and the W new will become will be changed, and there will be, let us say, some calculation, and now the W new will become 1, and the C new is also C old minus step size and derivative. So the C, so these are all hypothetical numbers, but what I want to tell you is that iteration by iteration our weight will change. Okay, in the first iteration we have to randomize the weight and bias, that is W and C. In the next iteration the weight is modified if there is an error, and this continues till for some iterations. Either the iterations are fixed, that may be 100 iterations, or maybe the error is reduced to 0. In these two conditions we stop this updation of weight and bias, that is updation of W and C. So this process is called gradient descent, and I will not go into the depth of this technique, but in simple words, what it does, initially W and C are 0, let us say, then the error is, let us say, 500. In the next iteration, W will become 0.5, C will become 0.5, error will become 400, and this continues. Maybe after 300 iterations, W will become 0.99 and C will become 0.01, and the error will become maybe 0.01. So either we have exhausted the iterations, or we have said that we can tolerate error 0.01, so stop. If either conditions, we are stopping, and we are getting our final model as 0.99x plus 0.01. So this is our final machine learning model. Now our data, if you recall, it was something like this: 10, 20 and 30, and our actual data is something like this. So the model, what will predict is something similar, like 10.01, 20.01, 30.01. So there is still an error, but we have said that we can accept this error. In this way, our model is learning the weight and the bias, or W and C, which is slope and intercept of the line, till we get the final model which satisfies our error expectation. Then we stop, and all of this is represented in this diagram. We are minimizing the error y minus y square, and we are finding A and B. So how to represent it? We are minimizing the error, so we are finding, so the error is y. Okay, so simply I will write the error is y minus y dash. We are minimizing this by finding the arguments W and C. We are finding W and C, which will minimize the error, because everything depends on W and C. If you take W as 1, C as 1, then you will get this line. If you take W as 0, C as 0, then there is no line, there is y equal to 0, which is the x-axis. If you take W1, C 0, so you will get some line like this, which is your ideal line. So we have to iterate till we find the ideal line. Okay, so this was how machine learning will work and identify the relationship in the data. In the next video, we will see some examples in Python of how this can be achieved. Thank you and keep watching. Bye.